Okay, today we're doing stretches and shrinks, and this isn't the last day of it by any means. We have quite a few more days to practice this, but I want you to get a really good feeling of how to do stretches or shrinks on equations. So take a look at these, and I'm going to show you how I think is the best way to tell if something has been stretched or not. Because I could look at all of these and say, yeah, they're parabolas. And I can't tell which one's actually been stretched versus not been stretched. Obviously, if I look at their equations, I can tell. But here, everybody graph the point 1, 1. I wish that was on here. There was a little mark right there and it said 1 and 1, but put a dot right there. Because that is the most important point. Did you know that every function, all the parent functions that we study go through 1, 1? That one, that's the x to the third function, goes through it. Even the butterfly one goes through it. Parabola, we already have up there, it goes through it. The V shape goes through it. 1, 1 is like the key point. So if you look at that spot and there isn't a dot there, like here, go down to this one. Here's where 1, 1 is, and it's not there. Pay attention. If the dot isn't there, then you got to figure out where it went. It's up here instead. Do you get that it's up twice as high as it was before? If I make this point 1, 1 and this point 1, 2, what changed? The y, and it went from 1 to a 2. That's how you could know that this thing was stretched. Here's a normal parabola. Goes through 1, 1, goes through 2, 4. It's not that much different. Goes through 1, 1, goes through 2, 4. That'd be the normal one. And this one's been stretched. It's like you grabbed a hold of it, like that's your fingers on your hand, and this is the fingers on this hand, and you pulled it up. Like it was made out of rubber, and you pulled it up, and you made every spot go twice as high as it was before. This spot's pinned on the bottom because if you're at 0, 0 and you double the y, it's still 0. All right, so I'm going to have you look at this one. What did I say was key spot? 1, 1. Everybody put a dot right where 1, 1 would be. This is the one that says 3x squared. Put a dot where the 1, 1 should be. Do you get it's not there? Do you get that it's up higher than it was? It's right there. Now you see how much higher it is. Well, I'm going to label this 1, 1, and this one's 1, what do you think? 3. And look, it's 3 times higher. It's really nice because we have a 1 as a reference point, because if a 1 turns into a 3, it's 3 times higher. All right, let's go over to this graph and see if it's been stretched. Oh, yes. There should be a dot right there, and the parabola should look more like this. But it's been stretched a lot. So I try to figure out where is it. Oh, look, it's up there. That means 1, 1 turned into 1, 4, and I can quickly tell from that that it's a stretch factor of 4. Is this making sense to you? Okay. Now I'm going to make another one off to the side here. Everybody find some room. What if I had a V shape? That's normal V shape. It's also known as the what function? Absolute value. Okay. But what if I took that absolute value and instead of going through 1, 1, I had it go like this? I'm going to label that. This is 1, 1, and now it moved over here, and it goes through there. And this spot is at 2, 1. What changed, the x or the y? The x changed. Changed from a 1 to a 2. Anybody want to take a guess what happened on this one? It's on the inside, because that's where the x stuff is. Anybody want to explain why it's not a 2, though? Yes? Can't trust the inside. And so you say, okay, it must be kind of like a 2, but it's not a 2. And so what do you think it is? It's a 1/2. Very good. Does it make sense that we tweaked its horizontal? That's just confused because it thinks we're in a different time schedule today. Doesn't, my phone's not set for Pep Fest schedule. Okay, it's horizontal on the inside, so that's a horizontal change. That 1/2, oh, so many complications. That 1/2 is really like a 2 because we don't trust what's on the inside. So it's like double wide, double horizontal. Get out the blue one here is twice the width. Every point on it is wider. Instead of going over this far, it goes over that far. Okay, let's move next slide. Take a look at these. Parabolas again. What's the key point to look for? 1, 1. Notice this one, it is 1, 1's right on it, and it hasn't been stretched or anything. So yay, it's supposed to be there. This one's 1, 1 is right here, and so yeah, it's not where it's supposed to be. But if you move over here straight to the right, do you get it doesn't hit at a lattice point? So that's, it was not moved to the right. Where was it moved? Down. See where it is now? You see how it's exactly down from where it used to be? Well then, y equals x squared is the normal parabola. And this one's been squished down. Did the whole thing move down? No, because it's still at 0, 0. So it wasn't a move down, it was a shrink down. And so instead of a 1, which would have been here in the very first place, it's a 2. Can I, no wait, it's not a 2. What is it? It's a 1/2. Sorry about that. That's a 1/2 in the front. If I look at the points, I think it'll make sense to you. That's 1, 1. That spot right there is 1, 1/2. What changed? That 1 turned into a 1/2. It was a y thing, which is like a vertical thing. All right, going over to this one. The hard part is they give you this on a test and they don't tell you the equation and you have to figure it out. I know you have one right up there. You know the answer already, but here's how you'd have had to do it. You say where it's 1, 1. Now, does it look like it moved this way? That's not a nice point. Does it look like it moved this way? Ew, that's not a nice point either. Ick. Well then, you just step back from it and look at it and go, well, I know it should be here. And so, I know, bad parabola, but I know it's definitely either wider or lower than it used to be. So I'm going to play around with the options. It's not something nice like a 1/2. Could it be something like a 1/3? Well, of course you know because you looked at the answer that it is 1/3. But how do you know you're right? Let me show you. If I think it's this, then when I put in a point like 1 on the, what do you think saves the day again? XY chart. I put in a 1 on the XY chart and I get 1, 1/3. Does that seem like it could be at 1, 1/3? All right. And I know this is tricky, and we don't usually give you ones like this because you can't tell because they're not on lattice points exactly whether or not you've hit it. But remember that this is, the whole distance here is 1. That is up 1/3. If the whole distance is 1, it's 1/3 of the way there. So that is the right answer. It was y equals 1/3 x squared. And this will be the hardest thing on your test. The test isn't until Thursday of next week. We've got plenty of time to learn this. Okay, so we'll be practicing in class on Monday and Tuesday, doing a lot of in-class problems together. All right. Take a look at this one. New function. Square roots this time. What do you think the key point is again? 1, 1. If we look at this original one, is 1, 1 on the graph? Yep, should be, and it is. Is 1, 1 on this graph? Nope. Got to figure out where it went. I could argue this either way, that this could be a stretch in the horizontal direction or a vertical one. But which one do I decide on? I pick based on which one has a nice lattice point. Do you get if I move straight up, it doesn't hit exactly where I would want it to hit? So I'm not going to do that. I'm going to do the horizontal. Do you get if I go over, it'll hit exactly where I want it to hit? 1, 1 hits at positive 1/2, 1. So it was the x that changed. That tells me it's a horizontal thing. That's why, of course, we know. We can just look at the equation that they give us right here. But I might have thought it would be a 1/2 right there. Remember, can't trust stuff on the inside. All right. So what's your homework for tonight like? Remember, on all these, all the ones that told us what the equation was. The hard part is, act like I didn't show you that. And you just have to look at this graph and go, what's the stretch? Like, start at 1, 1 and go, oh, well, if I go straight down, is it a lattice point? Oh, there is a lattice point right there. So I could do this as a vertical, and it's half as tall. Or I could do it as a horizontal move, because look at that. I hit another lattice point right there. And I could say it's 4 times as wide. So either half as tall would have worked, and that equation would have been this. Or if I want to go it this way, where I move to the right, 4 times as wide. 4 times as wide as a 1/4. Guess why this and this are the same thing? Because when you take the square root of 1/4, it's 1/2. See what I mean? That's why this one, you could have answered either way and been right. So look for a lattice point. That's the spot where those, where these little lines meet like this. And in this case, you could have gone down, up, down, or you could have gone left, right. So far, right. If you have to graph this, I'm going to just say XY chart, saves the day. If you forget that this was a V shape that got stretched up to be twice as tall, I'm going to say, why didn't you just stick numbers in, like 1, and you get 2, 2, and you get 4, 3, and you get 6, and graph those points. -1, it gives you 2. All right, so this kind's super easy. This kind's still super easy because I just use XY chart. The kind that they give you the equations. So on today's homework, I can't show it to you on the video, unfortunately, but it's under September 27th in the grade book, in Schoology, sorry. So look under today's date, which is September 27th, and you'll find the homework. I'm going to pause for a second when we all get there. Okay, so this is one of the pages from the homework, and they ask us what's happened here. This should be a pretty easy one. A second here. Square root of 3x. That's on the inside, so I know Mr. Server will want me to say horizontal. And then it seems like 3 times on the horizontal, which is stretching, but I gotta careful, it's on the opposite of what I think. It's on the inside, so it's a horizontal shrink. And 3 doesn't sound like shrink, so I go with 1/3. Horizontal shrink with a factor 1/3. You do that same idea here and here. Notice this one's on the outside, this one's on the inside. That right there is on the inside. All right, now, here's the ones that are actually hard. Can you tell if this one's been stretched? What point do you look for? 1, 1. Do you get there's nothing there? Do you see that there's another giant lattice point that's been called out here with a big dot? Seems like it's wider to me. Write the equation for it. Same idea here. 1, 1. Looks to me like it's pretty obvious they think it went up. And then that's now at 1, 2. Hopefully you can see it's the y values that have changed there. And then on the next page, challenging is the kind where